Okay, we'll start. This is lecture number 5.
Yes, sir.
And what we are going to do in this lecture, so CMOS fabrication. This is again module number 2. We have not completed module number 2. Today we will complete. It's CMOS fabrication. CMOS means complementary metal oxide semiconductor fabrication. So we will see what are the objectives. So first, to know various technologies for CMOS fabrication. Earlier lecture in the morning, we have seen how to fabricate CMOS and how to fabricate PMOS. But CMOS is how to fabricate the transistors in one process. That is called as CMOS fabrication. Okay. Then to know various steps, means what are the process steps for CMOS fabrication. And after knowing various technologies and after knowing various steps, so we will apply these steps for the fabrication of CMOS. So there are various steps. So after successful completion of this lecture number 5, so what you will know various technologies. What are the various technologies available for CMOS fab? Then you will know what are the steps you will be able to explain, and you will actually draw CMOS fabrication process flow. So see, what is CMOS? So you understand here, 3 pictures I have shown you. One is called as N-well technology. What are the different technologies available? So one is called as N-well technology. Other is called as P-well technology. And third is called as twin tub technology. So for CMOS, now why 3 technologies are there? Because you might have seen, if you want to fabricate NMOS transistor, you start with P-type substrate. Do you remember?
Yes, sir. Yes, sir.
Huh?
Yes, sir.
Yeah, you start with PMOS transistor, P-type substrate. And if you want to fabricate PMOS transistor, then you start with N-type substrate.
Yes.
But in one substrate, what you have to do, you have to fabricate NMOS as well as PMOS.
Both, sir.
So therefore, there are 3 technologies. So one is called as N-well technology. Now you understand what is N-well technology. In N-well technology, we start with P-type substrate. Can you see here P-type substrate? Okay. So in P-type substrate, we will fabricate NMOS transistor. And to fabricate PMOS transistor, we create N-well. Means in P-type substrate, we create N-well. Can you see this N-well here? So in N-well, we fabricate PMOS transistor. So therefore, in N-well technology, we start with P-type substrate. In P-type substrate, we fabricate NMOS transistor. And in P-type substrate, we create a well, that is N-well. And in N-type well, we create PMOS transistor. So such type of technology is called as P-well technology. N-well technology. Yes.
Okay.
P-well technology is different. P-well technology is different. So what is different in P-well technology? So N-type substrate is there. We start with the N-type substrate. And in the N-type substrate, we create P-well. In P-well, we create N-type transistor, or we create N plus transistor or NMOS transistor. And in N-type substrate, we fabricate PMOS transistor. So these are exactly opposite to each other. Okay. Here we start with P-type substrate. Here we start with N-type substrate. Right. So if you just forget about here PMOS, so this is NMOS transistor.
Yes, NMOS.
If you forget here it is PMOS transistor. Okay. So this is N-well technology. This is P-well technology. But what is meant by twin tub technology? So in twin tub technology, we create 2 substrates, separate substrates, 2 wells. One we create N-well as shown here. So N-well, we fabricate PMOS transistor. We create another P-well. Okay. So we fabricate PMOS transistor. So that's why it is called as twin tub technology. I mean, there are two wells. In N well, we fabricate PMOS, and in P well, we fabricate NMOS. So that's why it's called as twin tub technology, right? So we will understand our CMOS fabrication with respect to N well technology. Okay, so this one, first one. So let us start with N well technology. So N well technology. So N well technology start with P-type substrate. So this is P-type substrate. This is cross section. Somewhere else we have taken here cross section. From top, you see everywhere substrate.
Right? Yeah.
So this we start with lightly doped P-type substrate. Then next step, silicon nitride is deposited. Just see, we have deposited silicon nitride. So from cross section, you can see only from the silicon nitride is deposited on top of the substrate. You can see this. And on top, you can see silicon nitride everywhere because it is deposited. Next step is we use mask. And this mask is called as N-well mask because we have to create now N-well because this is N-well technology. And we create N-well in P-type substrate. So for that, we have mask. So this is called as dark clear field mask. This is clear field mask. Means everything is dark, only this much is clear. An earlier mask which we have used,
dark and then cleared.
These were dark field mask.
Yeah.
Clear field mask.
Yes.
This is dark field. Dark
this was
field.
light and that was dark field.
So this is called as dark field.
Okay, sir.
Field means ये जो बाकी का जो portion है that is dark.
Dark हो जाता
है. And that is clear field means बाकी का field जो था वो clear था. बाकी का portion. So this is called as dark field. And this is cross section. If you take the cross section, and this is dark. This is top view. This is marker. And this is used to create N well. So how it is created? So first we take substrate. You take the substrate. It's shown here. It is substrate.
Yes,
then silicon nitride is there. Then photoresist is deposited.
Yeah. And then we
is kept. Mask is kept.
Mask.
This is mask.
Yes, sir.
Then whole from the top, what you can see, top everywhere this is dark field, so you cannot see anything which is this is transparent. So from that you can see photoresist. Now ultraviolet exposure means this whole structure is exposed to ultraviolet radiation. Then exposed photoresist will change its chemical composition, and initially it is hard, so it becomes soft.
Okay, sir.
It becomes soft. So after exposure, see, after ultraviolet exposure, only this much portion will change. This is substrate, this is silicon nitride, this is photoresist, and this is N-well mask. So only this much portion is changed because this is exposed, and nothing will happen to the photoresist which is below dark portion and which is below dark portion. Then after this, we develop this photoresist. So when we develop the photoresist, so we remove that mask and nothing will happen to the photoresist because it is hard. Nothing will happen to the photoresist which is below that dark portion and so under dark portion. So from the top you can see silicon nitride. And why you want? Because you want to create here N-well. Then next is silicon nitride is etched away. So process silicon nitride is etching. So when it is etched, so basically this is kept in etching solution. So when you keep in etching solution, what happens? So this silicon nitride, only this much silicon nitride reacts with that chemical and it dissolves in that. Nothing will happen to the silicon nitride which is below photoresist. And this is this one. So next, photoresist is stripped away. Okay, it's removed. And then N-well implant is made. Means we make implant, then all impurities will penetrate only through this open portion and they create a well here. Okay, from the what you can see, everywhere there is a photoresist and only this much part, only from this much part, it is changed. Okay. So thus we have completed our first step, that is N well
Yes, sir.
is
Yes,
created. Then
Okay,
in
sir.
next step, we remove everything. Silicon nitride is east away. Then photoresist is also east away. And from top, what you can see, substrate everywhere. In that substrate, there is N well. Here it is N well from cross section. You can see that. Okay, now next is again silicon nitride is deposited. Because this fabrication is, actual fabrication needs hundreds and thousands of steps, small steps. Many times deposition is carried out, many times etching is carried out, many times metallization is carried out, like that. So again, silicon nitride is deposited. So when you do the deposition, this is top view everywhere. You can see that. And from cross section, you can see this N well is there, substrate is there. Now next step is, because we have to fabricate two transistors. You remember?
Yes, sir.
We have to fabricate two
Two
transistors, NMOS as well as PMOS.
PMOS.
So therefore, this is active area mask. In active area mask, there are two regions here. Can you see here? One and this is second.
Yes.
So here your PMOS will come and here your NMOS will come. Okay, in this region. And this type of mask is called as clear field mask. Clear field means only this much portion is dark and field is clear. Means backside portion is clear. That's why it is called as clear field mask.
Okay.
And from what cross section, you can see this much dark portion. And this mask is used to create active areas. So where actually your NMOS and PMOS transistor will come.
Okay.
Sure. Now, again, photolithography process for active mask. This is your silicon nitride. Then photoresist is deposited and then mask is kept. Whole structure is exposed to ultraviolet radiation. Then what will happen, wherever it is a transparent portion, this much portion of photoresist will change its composition. This much portion of photoresist will change its composition. And this much portion of photoresist will change its chemical composition. What? Let us see in next. So see here, can you see? So this much color has changed, this much color has changed, this much change. This change has happened. And nothing has happened to the photoresist which is below this dark portion, active area mask. Active area. It is hard and this is soft. So when I develop this photoresist, what will happen? This much part will dissolve. This much part will dissolve. This much part will dissolve. So this will be clear in next step. Yes. Can you see this?
Yes, sir.
So this much photoresist has gone. This much photoresist has gone. This much has gone. Dissolved basically in developing solution. And from the top, what you can see, this photoresist and this photoresist. Okay.
Yes, sir.
Now that you can see after etching silicon nitride, now we will remove this photoresist and we will etch that silicon nitride. So when you do this, so what you can see, just check.
So N and P and P and
this silicon nitride is etched here. Nothing will happen to the silicon nitride, which is below this photoresist, which is this below this photoresist. So that has remained.
Yes, sir.
After this oxidation, there is one more mask that is called a channel stopper mask. Channel stopper mask means it is used to increase the threshold voltage, or it is increased to enhance the isolation properties of channel. So therefore, channel stopper mask is used. So like this. So this is also clear field mask. And after photolithography, see, this is the photolithography. Again, so after photolithography, if you see, this much is the portion. So this is photoresist, this is also photoresist here. And when you make implant, P plus implant, it will go everywhere. See, can you see here? P plus has come here. But that is blocks. Actually, that silicon nitride and that photoresist block, that nothing will come below, nothing will come. So this is P plus channel implant. All right.
Yes, sir.
Then next step is silicon dioxide is grown. Now this structure is kept in oxidation furnace. In the morning, I have shown you oxidation furnace. So it is kept in the oxidation furnace. So when it is
Yes,
kept
sir.
in the oxidation furnace, this is exposed silicon. This is exposed silicon. This is exposed silicon.
That will go
Exposed
inside.
silicon, it will react with the oxygen or vapor, and oxide will grown
And into
here or
oxide.
created.
Create. Okay.
So see here. So this much portion oxide is created. Oxide is created, and from the
Again,
top you can see here photoresist. So this photoresist, this
yes.
photoresist, because photoresist yet we have not removed now. It's there. So
Yes, sir.
everywhere there is a oxide. So these two transistors are isolated from each other. Thick silicon oxide is grown using which works as field oxide. Field oxide means and which serves as purpose of isolation. So these isolate two devices from each other. Okay. Now this is substrate you can see. In that substrate there is a N well. These are the P plus imp. You can see which is used for the isolation. This is silicon nitride and this is photoresist. Now in next step, nitride is removed. Photoresist and silicon nitride is removed. What you see? So here see one substrate active
Yes, sir.
area for NMOS transistor.
Yeah, NMOS
And
transistor.
this you
PMOS
can see here
transistor.
for
PMOS.
here
Yes.
your PMOS transistor will come.
Yes.
Then now we will grow silicon dioxide. Means here because this region will act as channel region. So on channel we very high quality thin oxide is grown here. High quality thin oxide is grown. Again this is in oxidation, and now this time it is a dry oxidation.
Okay, sir.
That oxygen atom with the silicon, they grow the oxide layer, oxide. And cross section you can see. Then next is we have to create gates, and you know that in CMOS circuit, do you know CMOS circuit?
Yes, sir.
Or I will draw it here. One NMOS transistor is there, one PMOS transistor is there. Okay, okay. So this is N-type MOSFET, okay, and its substrate is connected to ground. P-type MOSFET, its substrate is connected to VDD, and both the gates are connected together, and both the drains are connected together. Here from here output is taken, and here we apply input. Okay, so here we apply input. So this is PMOS transistor, whatever I have drawn. This is NMOS transistor, and both the gates are connected together. Okay, both the gates are connected together. So therefore, now we have to connect both the gates of the MOSFET together. So therefore, mask is designed accordingly. So this is gate mask number 4. So this is NMOS gate, this is PMOS gate, and both the gates are connected together because this is CMOS inverter. And from the cross section, you can see like this. Now again, same process is carried out. What is that process? Photolithography process. This is your structure. This is polysilicon. This is your photoresist, and this is mask. Then whole structure is exposed to ultraviolet radiation. So when you exposed to ultraviolet radiation, what happens? Chemical, it changes its chemical composition. Its color changes. It is shown by change in color. So whatever is that portion, exposed portion, it becomes soft after exposure to ultraviolet radiation, and it dissolves in developing solution. So when it is dissolved in developing solution, only portion which is below this dark photoresist, which is below this dark area, that will remain as it is. So can you see here? This much only, and this much only. Now all other polysilicon is unwanted, so that polysilicon is removed. So see here, polysilicon is removed. So only this is gate of PMOS, this is gate of NMOS, this is gate of NMOS, this is gate of PMOS, and both are connected together because this polysilicon works like metal, and in CMOS inverter, both the gates are connected together, right? Okay.
Okay, sir. Yes.
Now, both the gates are there. Now, we will fabricate N plus mask. Means now N plus mask is used for N plus implant to fabricate source and drain of NMOS transistor. So this is the mask. Okay, again, this is called as dark field mask. It is not clear field mask. It is dark field because field is dark. So after photolithography process, so this is photoresist, this is mask, then exposed photoresist will dissolve in developing solution. And when this happens, so your next step is like that. It has changed its color. Yes, some change has happened in its chemical composition. It becomes soft. And therefore, when you develop that photoresist, so it dissolves only this much photoresist. And from the top, what you can see this portion, that is polysilicon. And now N plus implants are made. So when you make N plus implant, this is source and this is drain of MOSFETs are created. N MOSFETs are created. So N plus implant. Now similarly, we make P plus implant. Okay, so there is a mask. So this is mask. Okay, so when you make P plus implant, so this is P plus implant of PMOS transistor. This is drain of PMOS, and this is source of.
Yes.
So in this way, we have created NMOS as well as PMOS in one substrate.
Yes, sir. Tunnel tube.
Now, what we do, we remove photoresist. So when photoresist is removed, so from the top, your circuit looks like this. So these are connected together. Means both the gates are connected together. Now we have to make connections. What connections? In inverter, there is input, there is output, there is VDD, and there is ground. Okay. So in order to make the connections, we use deposit oxide. Insulator, everywhere we deposit insulator. This whole CMOS inverter is buried under this oxide. And then contact mask is used. So contact mask. So basically here, this contact is input contact. This contact this contact is drain of NMOS. This contact is drain of PMOS. This contact is source of PMOS, and this contact, substrate of PMOS, and this is source of PMOS. This contact is source of PMOS, and this contact is substrate of PMOS. Because in NMOS, substrate and source are connected together, as well as is PMOS, substrate and source are connected together. So when you do that photolithography process, it will be like this. And then when you do the etching, so it is like this. So it has made the window. So from the top, you can see. Okay, now we have to connect these two together. We have to connect these two together, and we have to connect these two together because this is drain of NMOS, this is drain of PMOS. In CMOS inverter, these are connected together. Now this is source of PMOS, this is substrate of PMOS, substrate, and these are connected together. and this is source of PMOS. This is source of NMOS, substrate of NMOS, and these are connected together. And this is gate. You cannot see in cross section. Cross section is taken across this, but if you take the cross section, you can see this contact also, back contact. Okay.
Yes,
and now
yes.
metal is deposited everywhere. Everywhere metal is deposited, and metal is making contacts to appropriate regions. But unwanted metal we have to remove. So therefore, what metallization mask is used. So this is the metallization mask. So you can see here in metallization mask, this connects two contacts, substrate and source. This is having two contacts, this drain and this drain. And this is having two contacts, that is source and substrate of PMOS transistor.
PMOS, yeah. Well,
so see, after etching means when you remove that unwanted, this one, so your MOSFET is CMOS is ready. So this is N plus drain, N plus source, and P plus substrate. So this substrate and this substrate are connected together and connected to ground. This is NMOS transistor. Then drain of NMOS and drain of PMOS are connected together, and output is taken. Okay. And from source of PMOS and substrate, these are connected together and it is connected to VDD. So basically this is CMOS inverter. Okay. But now there is one more step. So all surface is coated with some passivation layer, because there should not be any kind of corrosion and everything. So to avoid that, passivation layer is created, and some bonding wires are taken from each contact. So here we take bonding wire. So this is your ground, this is your output, this is your VDD, and from back side you cannot show here, that is your input. So for inverter there are 4 terminals: input, output, VDD, and ground. So in this way we fabricate CMOS transistor or CMOS inverter using N-well technology. Okay. Now suppose I want to fabricate P-well technology. What you will do? P-well.
P, this and
in place of N, you have to make P. So what so here you have started with P-type substrate.
So that will be N-type substrate.
N-type
N-type and inside P.
Yeah.
P-type is
yeah. Here you have to make P-well.
Yes.
N की जगह पे P-well.
P-well हो जाएगा.
Yeah. Here it will be P-well.
Yes.
P-well. Mask 2 will remain as it is.
Yes, same.
Yes. Now here
substrate N-type हो जाएगा.
So here you have to make N plus implant.
N plus implant, yes. Substrate.
Here you have to make then here you have to make P plus implant.
P plus implant.
Then here you have to make N plus implant. Here yes. N plus implant.
Yes.
Then rest of the things are same.
Yes.
And in this way you can have CMOS flow with N-well, this one, P-well technology. So I think that you can I think you will be able to give you this flow if you have understood this.
Yes, yes.
Okay. Any questions?
No, sir.
Yeah. See, I have uploaded all slides till last lecture. I have uploaded all on Moodle. So this also I will immediately upload now.
Okay, sir.
All slides.
So this all will be on the that wafer. No?
Everything is on wafer. Here just we are fabricating only one. This one inverter.
Okay.
Imagine that at the same time we are fabricating so many, because this process is going to each and every inverter. Yeah.
Okay.
And this is I have created on this one. I have put all those things on Moodle. All slides are on the Moodle available. Okay. And I have uploaded one prerequisite test also on Moodle. So you can
Okay.
just try that.
Okay, sir. Okay, sir. Yes.
Then can we stop here?
Yes, yes.
We'll stop.
Okay, sir. Okay, sir. Thank you, sir.